Okay, this is going to be a good day in non-foundational day. Distance and displacement is what we're looking at. This is vector stuff. You know how we looked at vectors, yes. Well, position, and we put an arrow over top of it to say that it's a vector, is the location relative to a reference point. And we've seen it before, we just didn't say what it is. Distance and direction is given. Okay. Now, let's come up with two examples. We're going to use Regina as our 0 point. Give me a place that we know okay, give me a place that's either more or less north or south or east or west of Regina. Yeah. Saskatoon, and we're going to say it isn't perfectly north, but we're going to say it north. Okay, now, I'm going to say Regina. R. Okay, that's kind of our 0. My drawing, I'm going to put north as up. Saskatoon, yes. To make my map, the position of Saskatoon is going to be 250 kilometers. That makes sense? That's its position. And that's relative to Regina in this particular case. Let's use one other community on the way to Saskatoon. Okay, no, that's halfway. Let's just go with, let's go with Chamberlain. It's about 80 kilometers. I don't know what it is. I find I don't stop there for ice cream because you're not even an hour out of the city. Davidson is back. Yeah. Maybe. On the way back. Yeah. You guys just like, hold your pee. We're still going. That's because he's not stopping again. Right? I'm a parent too. You will be like that someday. If you choose not to be a parent, that's fine. You're on the record saying that. Now, the next thing. Displacement is I'm going to do this. Displacement is a triangle in a delta. And it's a change in position. You're really behind things. Now, okay. Direction. I'll just type it. Thought it was doing it. No, no. I'd said it aloud before. I don't have too many issues. There we go. Okay, so you've gotten this down, a change in position. I'm going to give one example from our Saskatoon, Chamberlain, Regina. And then I have another one below. So. Okay. Now, obviously, if you went from Regina to Saskatoon, that your displacement is 250 kilometers north. That's easy. But let's just say you went. Saskatoon. Chamberlain. Displacement is, now we're going to go final minus initial. And I talked about this on the so the final destination is at a position of 80 kilometers. and I'm going to put in the n here. If you want for calculations, as long as you have one direction that's positive, you just put the n or the s in out. That's it. Yeah. Subtracting final minus initial. Initial position or the starting position is 2. Gosh, it's really low. So I know this is negative, and that makes sense because it's going south. I write it down as negative north. Okay. The difference between 80 and 250, that's 100. Don't ask me about that. Well, that's good. I don't need to help you. Okay. I put it as negative north. You understand that to mean the opposite of north. But depending if you have other calculations to do, you might want to keep it as negative north. Because when you do things, you have to have them all in south or all in north. Do you follow me? Instead of positive and negative signs for it. I'm going to put John underneath. That's the hold on. Hold on. As far as we understand, it means both. But I have another one. There's a town east just of the Calgary. That's the second. Or Odessa? I was just going to say they have cheap ice time. That's why. Okay. I'm just Google mapping. I forgot the distance to Odessa now. I think I was using 800 for Calgary, but let's see. Odessa. Sunny there. But it's okay. I'm going to use 60 kilometers for Odessa. I used to teach people from Odessa. It's actually really nice. So I know that it's 60 kilometers. Six kilometers between Odessa and Regina. And I purposely have given that as a scale. And you remember I'm using the word scalar on purpose. Scalar means I didn't give it a range. Glad it's there and it doesn't get erased next year. And 60 kilometers. Boom. And the right size. Okay, let's get this. The displacement. displacement in this situation. From Calgary to Odessa. So I'm going to go with Calgary. Calgary to Odessa. And back to Regina. I'm going on this diagram, right-hand side and left-hand side. What is the displacement in this scenario? How do we figure it out? Well, from Calgary to Odessa. From Odessa to Calgary is 825 kilometers west. So we know that it's east. Right. It's gone east. Or negative. Sure. We'll use negative. So I'm going to use that 825. And I'm going to put negative 825. And I'm not doing final minus initial. I'm just adding up the vectors. I did that one in blue. 825 kilometers negative west. Plus, and this will stay positive, the 60 kilometers west, which is going to come out to the east, but it's going to be negative west. Right? 865 or 765. Should be, okay. We could put east, but I'm going to keep it as negative west. Right? You can change it. I'm going to, I'm actually going to leave it this way. Just so you're comfortable in negative directions. Unless they say positive directions only, both are exact. Now, can I understand this? Now, here's the thing about displacement. I'm not going to. If you run 400 meters around a racetrack, the distance you've done is 400 meters, right? That's a standard track. So I went like this. That's 400 meters of distance. Now, your displacement in that case would be 0. Why? Because where you started and where you ended up is the exact same place. Does that make sense? Distance, 400 meters, displacement, 0. Round trip. So we're going to be really anal retentive about what words. For position, it's not a distance at all. It's just a position from the starting point or ending point or something. The distance we've talked about. It's a scale. It describes the length of the path traveled by an object. I think that's straight ahead. It's what your odometer and your car will do. Right? And then that Regina to Odessa, or Calgary to Odessa, then back to Regina. We'll do that with that. Calgary to Odessa, and Regina. Right? So it's the same trip as above. So if I don't have that little arrow on here, I'm going to erase that. If I don't I have that, that's the answer about negative 765. The minute I just write down the D, change distance. We're doing absolute values. There's no subtraction involved. It's 825 kilometers to Odessa from Calgary, and plus the 60. So, what your odometer on your car would read, and I made these numbers easy, 885. Practical reasons, like how much gas you're going to use on this truck, 885 is really what you want to know. And for time reasons, how long will this trip take you? Well, we got to drop everybody off at Odessa, then come back to Regina. You can figure that out. Well, it'll be around 9 hours. 885 kilometers. That's without P stops. It's east of town. But it's on Highway 48. It kind of goes a little angle. At White City, you can take a highway that zips out. And it's more or less probably starting Calgary. Odessa is more or less south of maybe Coppell, not Fort Coppell, Coppell, maybe. Go to the town. Fort Coppell is in the valley. It's quite beautiful. Yes, it is. That's why I talked. Jot this down, sons of guns. I'm back. Done. Okay, we travel 2.5 kilometers east, and I'm going to do this by math, but we're going to have a sketch to just kind of understand when I say math. I'm not going to do a scale diagram here. So if I say east and then I go south 21 degrees, well, like I said, I was going to get my arrows out that are straight. So I'm even going to sketch it so that it's all my signals. So how much space? 2.5. If this represents 2.5. Drawing a little one. 2.5 kilometers east. And I'm using the traditional up and north. That's what I'm just going to say. Yesterday. That's exactly what I'm going to do. Right now. Followed by 7 kilometers south, 21 degrees east. Now, this means south. We know north and south. Right? And when you give a combo direction, it's kind of going southeast, but it's not going down the middle, 45 degrees. So you always give the north or the south first. And here's what I'm thinking when I see it. South, I'm going to erase it. This is straight south. But then, you know how it's north, east, south, west. I'm going south. And then east a little bit. So what I would do is think, and this won't show up on the video here, but 21 degrees, I'd use a protractor for directions to the east direction from south. So 21 degrees. Like that. I'm going to draw this, and often I will, if I'm doing a sketch, I will do a dotted line. I'm not measuring. And I'm just kind of approximating. This is my 21 degrees. And I will put the dotted line south there just so I can approximate. I'm recommending you do the same so that you understand what it means to go south. I don't want to do this. But this is just to understand. So the total distance and displacement are two different elements. The displacement is, some people say, as the crow flies, right? You would have traveled what is on the two red arrows That's the total distance. The displacement is what we're going to have to calculate the distance per unit. The displacement I'm going to do, I'm going to draw this and this way. I should put down. This means we need calculators and sine and cosine. Follow the right channel. Okay, the total distance is pretty easy. We can do this one in our head. Total distance, it's 2.5 plus 7. Okay, that one's no problem, 9.5. This is kind of like if you were going on Victoria and then you turned on to Arcola. Now it angles like that, like about 21 degrees ish. I'm saying it's a problem. Yeah, those two, like that's what I'm saying. It's not a straight 90 degrees. There's anything Arcola is just like a lot of aren't. Total displacement though, that's the one we have to figure out. Crap, right? The displacement is what I have in green. So I'm going to say let's organize. So I am going with the first vector. These are vectors there. So this is figure out B. We're going to have an east column. And we're going to have a south column. And I chose both south and east because I could have chosen north and west, but these are going more or less south and east. You've got to just make a choice. But it makes more sense. Now the first vector is 100% east, 2.5 kilometers, 0 in the south. It's the next one we're going to have to use sine and cosine. I'm going to draw in another dot. So what we're saying is that 7 kilometers with this 21 degree angle here is the same as going this way and then this way. You'd end up at the same spot, right? How much did I go on and ask it for each? So it depends where your angle is. 21 degrees, but I also know that that 21 degrees, if you now 90 degrees is the other corner, right? If it helps you, you can say, well, that's 69 degrees in this corner. I don't care which, like, you know, it's a number. Anyway, 69 degrees here. Whichever, if you like, you get the same math, but your sines and cosines will be different. I really don't care which one you use. So, to figure out the east portion, mathematically using sines and cosines, how do I figure it out? Got the hypothesis. And we want the, now which angle are we talking about? 69 or 21? Okay. According to that 69, this is the opposite or is it the adjacent? The adjacent. So AH comes from, so cosine. So if I go with 7 degrees, or 7 kilometers, the cosine of 21 degrees. Not, you're using the other number. Right. Opposite. 69 degrees. That is going to give me the east direction. This should make sense to everyone. This is B. We're figuring out the east component of 7 kilometers south. I can't do that in my head, but you got to make sure that your calculator is in degree mode Are you guys going to take a pre-calc 30? You're going to be doing radian mode sometime, maybe not yet. Eventually. You know how there's modes? I'm just making sure my calculator is in degree mode. It is now. So 7 times cosine 69 degrees. This happens to be by coincidence 2.5 kilometers. But do you guys see why it's 2.5 kilometers? Nothing to do with the previous vector. Then we got to figure out how much south you went. So the south part is going to be the sine function. It's the opposite of 7. So 7 kilometers trying to squeeze this in sine 69 degrees. Which is equal. 6.5. I'm going to put the 6.5 kilometers in. Okay. Yep. I was excited you're going to have physics. No. What we just figured out, my diagram over on the left has got kind of messy, is that going this trip right here to the end is the same as going 5 kilometers east and straight down 6.5 kilometers. That's what we just figured out. I did it disappearing because don't do it on your diagram, but that would be another way to get to the same end. Make sense? What we figured out mathematically? Now, this doesn't quite answer our question. The total displacement is the green arrow. Two 2.5 plus 2.5. So, like I said, it's going to get too messy if I draw over top. I use this grenade because I'm now going to just fresh draw this. 5 kilometers. Whatever I put a 1. That's what this represents. 5 kilometers this way, then 6.5 is my green. Really what I'm trying to find. Right? This is the same simplified drawing on the left without all the work. But now I can clearly see what I want. How do I find that green side if I'm given 2 sides? A squared plus b squared equals c. You don't have the angles yet. Use the Pythagorean. So I'm going to go with the green. So this side is, I'm just trying to say, I'll just call it x for now. It's equal to the square root of a squared plus b squared. So 5 squared plus 6.5. And run on. I get 32.5. I shouldn't though, because I typed it. Yeah, I just looked up. 8.2. Tangents on run. Okay, that's just the side. That's not the displacement. We need an angle. And this angle has to be measured. We know it's going to go south, some degrees, and I'm leaving the space, east, right? The way I drew the triangle actually is intuitive. What I'm saying is 5 kilometers is the same. Yes. That, which is stuck in which. Sort of just trying to recycle some of my not working. I won't do that. I'm going to redraw this. It's the same thing. But there we are. With our 5 and a 6. I need to find this angle. Right? I redrew the triangle the other way around. You can do it because I want to be able to find this angle because I'm going south. Then how much over to the east? That's the degrees we're trying. That's right. Which is that? That's opposite and adjacent. What's that? So what trig function is opposite and adjacent? No, opposite and adjacent. What is it? 10. So we're going to use the inverse function of 10. So I'm going to go tan negative 1 up opposite 5 over 6.5. I'm leaving the kilometers up to 5. Huh? And function 5 divided by 6.5 in the bracket. I'm doing the inverse. 37.6 is the round. So I'm going to go with 38. Now I know what that is. I'm going to present the answer. The way we said it was changing our total displacement. Give it that. 8.2 kilometers south, 38 degrees. I'm going to do north and south first. Degrees and then. Does this make some sense to us? It's like, I mean, math-wise, you just haven't applied it, but yeah, the math itself, here's this as a guide. Lots of information. Heads explode often. You still haven't finished this, though, have we? There's C, and its position. Where's from the starting point? So if your displacement was 8.2 kilometers south, 38 degrees east, what's your position from that starting point? It happens to be the same right now because the starting point we're considering 0. Okay? So I'm going to just take the easy way out and say, don't work, you see, not the final position is the same thing. And I'm going to just do this. It happens to be the same thing. No, But if the 0 is the starting point, but do you understand why it's the same thing? Here's why it's the same thing. If this is considered 0 right here, and you end up, I'm going to just say, 8.2 kilometers away, that's your displacement. It's also your position away from the starting point. It's not always, if we figured, if for some reason, change this now, erase this. If for some reason we said this 0 is some point that was north of that, we'd have to do a whole new set of calculations. It would actually be, the position would be this distance, the black thing there. I'm not going to mess up the diagram too much, but as long as your 0 is your starting point, you're going to find shit. I'm not going to be crazy. If I do different starting points and positions, I'm going to put back to that this calculator. I'll show you the difference. So we use 0 as your giant, right? Now, just to I use milestone. Just to get, and this, don't copy this down, but I'm just milestone, and let's say that milestone is, I'll just guess maybe it's 60 kilometers. I don't know. Its position is 60 kilometers. If I ask you for the displacement, you don't, I'm doing this because you can do this in your head. If I ask for the displacement from Chamberlain to Miles, the change in position, you would say it's 60 kilometers. I'm going to make it final minus initial. I'm going to make it so. And then final minus initial. Minus. Now, I have to use the same system, whether it's north and south, or I chose south. Minus negative 80 kilometers. South. Now, the arithmetic is easy. You actually add, so it's 140. You can do this without vectors. You guys follow this. That's your displacement. You go from Chamberlain to Knox. So, follow me on this? Here's Regina. In the middle, well, not double, but in between Chamberlain and Milestone is south. This is kind of a map. So if you go through this, you've traveled the 80 kilometers to Regina and 60 kilometers to Milestone. That's where I get the 40. Not 20. That's why I took the negative south. Yeah, Lumsden. If you would put Lumsden in here, then that would maybe be 20 right there. But what I wanted to point out is that your final position in that case would be different. 140 kilometers south. This is back to Rose's question. 60 kilometers south would be your final position. You guys follow that? That's an example where your final position and your displacement aren't. That's all. And that's because she asked. Okay. I think I just read this question. I'm going to just save and stop the recording because I got some questions for you. So, stop this.